All right. Good evening, everybody.
Good
Uh, yeah, it appears I underestimated, the previous session I had. So I had a class, I'm transitioning with different class, and supposed to be 45 minutes, but there were a series of questions that I had to address. I do apologize. It's a good thing that yesterday we went slightly uh, beyond the planned 1 hour that we wanted to cover up for, if you remember. In any case, we're going to continue our discussion of lecture series number 1. I don't call this a module really, not a lecture, but I don't think it matters what it's called really, because what you notice is we are covering a whole bunch of things as they relate to the Python programming language. I call these modules. I think I'll need to change this. Also, just to mention that I shall update the presentation slide deck on the Google uh, on the Google Classroom site, because I've made some changes to this slide deck, extensive changes actually. In addition, what I'm doing is I'm finalizing uh, notebook for problem sets. I think there was a question, there was a contribution yesterday where one of our colleagues proposed that I also provide problem sets. If this were an undergraduate course, we probably would have, I think, what you call tutorials or something, tutorial problem sets. So what I've done is I've started working towards problem sets, and hopefully by, I believe, tomorrow, I should be able to share these problem sets. But yesterday when we met, we parted ways when we had started looking at functions. Okay, and we introduced functions as being this really elegant way of trying to handle what we introduced as reusable code, is it? So it turns out that there are instances when we may want to reuse functionality over and over again in multiple segments of code, if you will. And what we said is the ideal approach is to encapsulate everything into what we introduced as a function. I mean, there's different sort of ways you can do this. For instance, you can work with classes, libraries and stuff. It's just a way of packaging code, ideally. Right? So a nice way of thinking about where exactly in the grand scheme of things these functions fall under, you'd be defining these functions in what's called a module file, a .py file. Okay? And typically, a .py file would be a part of modules. Modules would be part of libraries. And in fact, when you install a library like, for instance, Python Pandas, which is what I'm going to showcase here, I'll change into our environment, our data science environment here. If I go to the library and I go to site packages, these are the different things that I've installed, right? These folders here, these are libraries, I call them libraries here, that correspond to this pip list here, all of these things that I have here. You notice that I've installed things like PyDicom, NumPy, which we're going to look at. It's weird things here like Seaborn, Matplotlib. So in essence, something like Matplotlib, we say that if I go into Python and I say import Matplotlib and I use the help built-in function and check what Matplotlib is all about, right? It's a library. Now, it turns out that the way when you're installing this library, all you're doing really is you're downloading files, right? and you are copying them onto your file system. So there's a folder called matplotlib here. It's here. It's in here. Right? So within here is where you have a series of modules and stuff. Modules and stuff. So if I search within here for pyplot, I'll be able to find it somewhere. Right? There's a file here, pyplot. So the thing that I use when I say import matplot.pyplot or something, it's like I'm using the pyplot module, is it? So if I come here and I say, Python, and I say import matplotlib, it won't import here because I need to be in the root, sadly. And I'll go in here and then I say import matplotlib, like that. If I check dir, or if I check matplotlib.pyplot, is here, is it? Pyplot. In fact, I should have done it's a merge, say import matplotlib.pyplot, like that. If I try and check the help built-in function to check what is matplot, what pyplot is all about, right? It's unfortunately it's not. It's a merge, right? It's supposed to be a merge. It's not indicated here, but you get the point, right? You're just copying files across. It's the point I was trying to put across. No pun intended, I suppose. So pretty interesting stuff that we looked at yesterday. I want to continue our discussion. So we had gotten to a stage where we were looking at, done quite a bit here. We were looking at these functions, is it? Yeah. We're talking about scope, variable scope, return values as they relate to functions, how we define functions, the signatures and stuff like that. And then we go to a stage where we're discussing the so-called built-ins. And I mentioned that there are a whole range of built-in functions, if you remember. A nice way of knowing which built-ins are available is you use the built-in modules, is it? You import built-ins, not ins like this. And then you just do a dir, use a dir built-in function, which is interesting, is it? It's like you're using the thing that is defined in built-ins to check the things that are in built-ins. Wow, right? So one of these built-ins is the one I just used here, the dir, right? dir here. If I check what dir is all about, I can use the help built-in function, right? It shows attributes of an object, any type of object, anything that I will import from elsewhere and stuff like that. Yeah, so we realize that there's a whole range of built-ins, right? Some of them are utility functions, you know. I don't know if we've gotten to a stage where, yeah, we're looking at these built-ins. Now, something I didn't talk about, we looked at print, right, which prints things, anything, any object that you want to print, anything you can think of. You just pass it to the print function. So someone already defined the print function as follows: define print, and then they had this. Then they said enter. They defined it like this, right? So for us to use it, we know that we can just pass it anything. I'll pass it an int to print the int. I'll pass it a float to print a float. I'll pass it a Boolean value like true to print true. I'll pass it a Boolean value like false to print false. If I pass it false without lowercase f, it's an error because there's no false here, right? It's not defined. I can print a list. I can print everything using the print built-in function. It turns out that there are instances where, and I just realized that I didn't include this under input-output. There are instances where you may want to create, let's say, an interactive program, right? Like, let's say I want to create a function that will add numbers, but add. It will take in two parameters, var var underbar A and var underbar B, or it could be var underbar first number, if you wish, var underbar second number. I want to be more descriptive. And then in this particular case, I'm going to say I want to return, or I want to define a result. I'll call this final result. Final result is going to be equal var underbar first number plus var underbar second number. Afterwards, I will return var underbar final result like this. This works. If I invoke the function var fxn underbar add, and I want to add -10 and -20 so that I get -30, it works. But this is not nice, is it? I guess, I don't know. You may want to define this in such a way that it's reused somehow. And I want to explain how chaining is done. You want it to be able to work in a certain way. And I think for this to make sense is I'll say, I also want to multiply mod var first number, var second number, var final result is equal to var first number multiplied, it's asterisk, var underbar second number, return var underbar final result. So that when we call mod by what do you call this? By evoking the same parameters as so arguments, 10 and -20, we get 200, is it? -20 times -10 is 200, positive, negative and negative cancel out. But you notice here that it's not very nice, not very elegant. Let's say we have two numbers and want to perform different operations on the same numbers. Well, what may be desirable is you prompt a user to enter numbers. So you can use the input built-in function, right? It elicits input. Observe input. If I just say enter here, it will ask me for an input. I'll just say Lighton, enter, right? There goes out Lighton. But it turns out it accepts an argument which acts as a prompt. So I say input enter number. You see that? You say enter number. I'll just say I want it to be a 4 or something. It turns out that you can assign this to a variable. So I'll call this var, I'll create two variables, var first and var second. Say var first is going to be equal to, now there's something else that's interesting. The return type of input is always a string, irrespective of what you enter in the prompt. Whether it's true, observe, whether it's the value true, it will be a string. So what you can do if you're working on numbers is you have got to cast it, you change the type. So observe, if I want to reuse the add and the multiply, I can define two numbers. It's like I'm going to prompt the user to define two numbers, right? Enter first number, and I'm going to prompt the user. But because enter the first number, like so. But because this first number, if let's say I enter 5, is going to be a string, right? If I check the type of var first, it's going to be put in var first here. Because this is going to be a string, what I can do is, when I'm prompting the user to enter the first number, I can tell Python to say, I want to convert this string into an integer because I'm going to be working with integer values. So that when I enter this, let's say it's 5, and I now check the type of var first, it's going to be integer. So you notice how this is working, right? I can prompt first number, integer. It says it's 6. and then I can prompt second number, which is going to be again int input, enter the second number like this. I'll say this is 50. And what I can then do now is I can just evoke add with var first, comma var second. I know it's adding the numbers I've entered is 56. I can evoke mode with the same variable, same two variables, right? 50 times 6 is 300. Okay.
Doc.
Yes.
So say if you wanted to change the input using the as type method, can it also work here, or this is the only route we can take in such a situation?
Well, I mean, you can. So the thing with the as type method is it works on an object, right? Is it?
Yes, yes, yes.
It works on an object, right? So, for instance, it's quite common actually. It's quite common in. I think you do this in. I know we should be able to do this in things in libraries like NumPy, for instance, right? In Python pandas, right? But not natively, if you will, right? I guess it should also be possible to do this natively. I don't think so. It's like so the as type it requires a dot operator, right? I don't know
Yes.
in what context you've used it. You've probably used it in Python pandas or something, I think, or maybe NumPy.
Yeah, it's pandas.
Yeah. So the thing is, if you say import pandas as PD, right? The idea behind this is that you may have something that you've extracted from Python pandas and you want to change the type. So you evoke the as type function. I don't know if I do PD here, we'll be able to see as type. I don't know. Can't quite figure out. It may not be possible here, but if we go to pd.series maybe, yeah. So if we go into series, we should be able to see as type, I guess. I don't know. L. Here, you see that? So
Yes.
it's not. So here's the thing, right? What you're as type is a method. It's something that is defined within an object, an already existing object. Whereas the things that I'm showcasing as examples here, these are functions. They're standalone. Yeah, that's a nice whole thing about this is like the class method, right? Class method, I can't just say I want to change this to lower by just saying lower. There's nothing like lower here, like this. I can't say lower. This will fail, right? I have got to evoke the lower function. It's a method now using the dot operator, dot lower, right? So it's like it's acting on a string object. So as type is typically tied to specific objects, right? So there are certain types of objects here, like, NumPy, Panda specific types, for instance, that you can utilize ideally. Okay. So we shall see the as type, I guess. I don't know. Maybe not. When we discuss Python pandas and NumPy, we're supposed to have in-depth discussions of these packages. And because this package is actually quite rich, you notice how just a series alone in here, these are all the different sort of methods that you can play around with. I mean, we can't really look at all of these, right? Some of these I haven't even used myself. I've seen used describe, FUNA and stuff. Just like a data frame, right? It has a whole range of things associated with it. Anyway, I don't know if there's any other questions about this. Glad that we're trying to piece, different pieces of the puzzle
Ah,
together.
understand. Thank you.
All right, great stuff. Okay, so we had fun here going through some of these examples. I'm glad that some people are following through. At some point, I foolishly, and those are common mistakes, but there's sometimes you will do something. I thought that was really strange here. You do something that would be a logical error. Okay, so problems with code are referred to as errors. There are different types of errors. You have syntax errors, you have logical errors, compilation, interpretation, I guess, runtime errors, and all those things. If you remember last time, right, when I was trying to showcase the filter function, built-in function, it was failing with the function as defined, right? And it turned out that when I was defining the function, right, which I had called A+, I believe. I remember like it was yesterday, which it was yesterday, though. A function called A+, which takes in a score. I said this thing just checks, is it? If var score is greater or equal to 86, then this thing is going to return true. But what I was doing is I made a mistake. I just wrote true, right? And then here, I just wrote false like this. It worked, but this is a logical error, right? Because this thing was not returning anything. And so when I ran the filter here, if you remember, we defined a set, right, which had 45, I don't know if it was 45, 56, or just 78, 90, or something, and I don't know, 87 or something like that. We call this list var all scores or something like that is equal to this. I was trying to showcase this, right? The fact that I can run filter using these functions, the specify filter function, A+ in this particular case. And then I was saying I feed it var all scores, like so. But you see, when I cast this to a set and I check, it wasn't giving us the things we wanted. It was giving us an empty set. Well, it turned out that there was something wrong with this definition. I'm supposed to return here. Because the way filter works is it expects, this thing has got to return a Boolean value. So true to that, if I come back here and I rerun this, it will only return, if you remember, we have var scores like so. Var, okay, it's all scores like so. And so what I can do here is I can run this function, right? And now it will return just those that conform to the thing. And so you have to be careful about these errors. Sometimes it requires that you debug. Back in the day here, it was tough debugging when I was a student myself. I remember when I was learning how to program in 2004. Right? Because 2003 I was doing physics, maths, biology, chemistry, right there. And in 2004, I was introduced to programming for the first time. You compile the Java file, and it's failing. Errors, compilation errors. What is wrong? But anyway, there'll be all those things here. Okay, so hope this is making sense. I'll just ask that we maybe mute ourselves or something so that we don't have a lot of echo or something like that. All right, so we look at all these series of examples, which is pretty straightforward, is it? But so it turns out that yes, there's a question. Yes, sir.
Yes, Doctor. I wanted to find out. In my code, if I used a print instead of the return, would it still work?
Yes, it still works, but context matters, right? Context matters. Observe. Logically, it will work. Observe. I'm going to use this other example, which I think I use. I'll use a simple example here. I'll define two functions, Great question, Mr. Kalingasa. Thank you. I'll define two functions. They will both add. I'll call this add one. They will all accept two values, first and second number. I'll call them first and second. Right? Syntactically, this will work. The first one, I want it to return the result of adding var first plus var second. It will work, right? The second one, I will call add2. It will take in the same number of parameters, first and second. Right? And then, in this particular case, I want it to print. Now, here's the thing. Whether I'm printing or returning a value is inconsequential. This thing does what I want it to do. It adds two numbers. Okay? Function 1, function 2. I'll test them. I will test them by invoking function 1 first. I'll give it 1, 2. What does this tell me? 3, right? I will then run function add2. I'll also run it with two arguments, 1 and 2. Right? This is horrible stuff here. I should not have comma 1 is plus. Logical error. This is called a logical error, by the way, where the function runs just fine, but it gives you wrong things. So observe, I have function number 1, which is add 1, right? I'm evoking it with two arguments, 1 and 2. 3 is the answer. I'm going to evoke function 2. I'll evoke it with the same arguments, 1 and 2. It gives me 3 as well. It runs, right? The only difference is if I check the type of this first function here, using the type built-in function, it tells me that the type of the result of this is what? Int. If I check the type for the second one, 2, it tells me the type is none. And the idea here is simple, right? What this thing does is, it's almost like, how do I put it here? There are use case scenarios where you would want the result here to be an integer because it's supposed to be processed in some numeric logic or something like that. So this is where return becomes important, right? In instances where you want to use the result of this function as input elsewhere and that input has got to be an integer. Right? This won't work. Like for instance, what is this? Let's say, I have another function that tells me if this is a pass or a fail, a score. I'll define this to say if var score is greater or equal to 50, I can use print here. This is a pass. Otherwise, it's a fail. Now, let's say somewhere in my program, I have two values. These two values are scaled values for CA and exam, where I know that 60% of the CA is a value. If added to 40% of the exam, that value when checked is what's going to tell me whether somebody has passed or not. So I would say var CA scaled is, let's say, 30, which is a 60%. And var exam scaled is, let's say, I'll call this maybe, let's say 40 or something. I know that for me to check if the final score, the way I compute the final score is I've got to add CA and exam. For me to compute the final score for CSC 6741, I've got to add these scaled down values so that I get 70. So what I would do then is I would say, well, for me to check if this person who has a scaled down version of the CA as 30 and exam 40 has passed, I have got to run CSC this with some score. What score is that? I'll use FX add, but I'm not going to use 2, right? I'll use 1 here, because 1, when I feed it CA and I feed it exam, is what's going to tell me, give me the right thing. If I run this with 2, which prints, this will not give me what I want here. It will fail, right? Because that thing does not return a value. I don't know if this is making sense. I don't know if this example makes sense. The idea is the question borders on. So to answer your question, no, it won't return an error if we decide to use print statement rather than a return statement. But there are instances where you may want to use one over the other. And in most instances, you want to return something. Most of these functions, observe, input, okay, input. If you look at the thing here, why doesn't this, and this is a horrible thing here. They're not even telling us, okay, how about type, help? They're not even giving us, yeah, these doc strings are not even helpful. They're not telling us, but we know, right? I mean, type returns something, you know, all of these things will return a value. Anyway, all right, so it's contextual. Either one will work. It just depends, you know. Another way of looking at this is that if you're dealing with intermediate results, in most instances, you want to return something. Whereas if you're trying to process a final, the end result, printing is fine. But then again, also printing may not really work, because what you're doing when you're printing, like if you're printing something, is you're printing to standard output, or you can output it to a file, by the way, right? This print here. This print here. You should be able to printing it to a file, maybe not anyway. But so imagine you're building a graphical user interface application. Like printing to standard output is not going to be helpful, is it? You know, so what would be helpful is you are, here's the thing here. You're building a calculator. You're building like a calculator like this, huh? It's a graphical user interface. You're not going to be using print. You'll be returning values, right? So you define a function, for instance, that adds numbers, so that if a user like Lighton is saying 8 plus 9, and then they press equals, it will show them 17. So what you're doing is, you're writing the logic such that the first number clicked, pressed, you're capturing events here, mouse events, right? If I press 8 here, press the 8 button, I capture that somewhere in a variable. And then I say plus, that's operator. I have the second number, 9. The moment I press equals here, I'm performing addition, right? But that addition shouldn't be printed elsewhere. It should be held in a variable such that what I'm showing in this text field here, because it's a text field here, is going to be the thing that is in the variable result or something like that. I don't know if this is making sense, but is that helpful?
Yes, it is. So if I have intentions to reuse my output, I should use return. But if I just want to display the output, I can use print.
Yes, exactly. Anyways, so we had a discussion of built-in functions. You know, I mentioned that there are so-called lambda functions that we'll discuss here. In case this is confusing, I had a reimplementation. This is called an anonymous function, is it? When you represent something like this in a code constructor, it's an anonymous function because you're not using the def function. So it's only going to be used within the confines of this code construct here. But more on that later on. So our discussion of functions leads us to this concept of a function and the method, right? The whilst they may be similar, fundamentally they are different. They perform the same function, they help you encapsulate code and stuff, but they're fundamentally different in terms of how you evoke them ideally. So in essence, your so-called functions are standalone, right? These are standalone encapsulation of code ideally. So they can be invoked independent of any other existing objects. And you've seen us use input, len, type. I've been using dr, right? All of these are built-in functions. However, there are similar code constructs that are referred to as methods, right? So these will be functions that are associated with an existing object. And so what you do is you evoke them using a dot operator. In fact, this is quite common with the libraries that we're going to be using, like matplotlib or NumPy or Python pandas. You'll notice that we'll be doing crazy things like import NumPy as NP, and then you say NP dot array, for instance, right? Say create an array, an NumPy array with these objects, and d type here is equal to np.int or something like that, or d type is equal to int32 or something like that, 32, right? So you create an NumPy array like that. You notice that I'm using the dot operator, right? This is a method, ideally, right? So these things are used contextually, right? You would want to use, you typically would use these things when you're dealing with complex objects that have a whole range of operations associated with them. And I want to draw attention here to the thing that we've discussed already, a string. If you have a piece of string, right, it's unlike a number here, but if you have a piece of string, let's say CSC 6741, there are so many things you may want to do with a string. You may want to change the casing. You may want to extract the characters, right? In fact, when you're changing casing here, you may want to change it to lowercase. Is it a string like CSC 6741 can be represented in so many ways, right? All lowercase CSC 6741. Title case, which is the first one. Uppercase, which is the first one. Title case CSC 6741. Camel casing CSC and stuff at 741 or something like that. Now, for you to get different variations of this string as it relates to casing, you'd need some sort of function, is it? Now, your immediate intuition would be, well, I'm sure there should be a built-in function for lower, up, and stuff, but that's not sustainable, right? So instead, what you do is you attach functions that are specific to strings, right, to that string object. And true to that, if I just check dir for a string, it will tell me that these are the different things that I can do with a string. I can find things in a string, right? I can replace, like I have this CSC, this thing here. I can say, please replace, I don't know if it's going to work here, but replace I want you to replace C with an A, right? There's such, I mean, I can't really think of something that you may want to do, but maybe not, or something like that. I've made a mistake, and it's not supposed to be CSC, it's supposed to be ICT or something like that, right? I don't know. You may want to, you have a huge string here, right? Like, okay, Python period or something. I want to split this, the full name of the person, onto first name, last name. Well, split it. I'll use the split method, right? It turns out split cannot be used as a built-in function here because it's specific to string. So what makes sense is you define it as part of the string object. And that's all of these are called methods. And by the way, string methods, there are quite a number of them. Is lower checks. It's like check, is this string CSC 6741? Is this lower? Is lower? You know how is, if there's an is, it's like it returns a boolean, right? False. Right? But if you check this CSC all lowercase here, true. It's like it's a string made up of lowercase or something. But also there are a lot of them. I don't know if you like strings. Everybody likes strings though. If you think about what you do with in Excel, I don't know if you've played around with strings in Excel. Left, I don't know if you've done these crazy things in Excel. I do this a lot, and I know it's retarded, but I don't know why I'm not recording this. This is sad. I don't know why I didn't record this. But you say left, you know, and then you specify, I want to, so if you have a string here, like item period or something like that, you do crazy things here, like I want to get the left, the first 5 items here to the left or something. Or in fact, this is a good one. CSC 5019, CSC 6741 or something. I don't know what else you have here. I'm going to create a formula which is just going to extract the beginning code here, or the last code. The beginning code, I guess, the code is like left. Just give me the first 3 characters so that I just get CSC. Okay, how about the actual number here? Well, just give me, how do you do this though? The first right. Right. We started doing Excel here. Get the first right and do a whole bunch of things here. And I guess it's like 4. This will give you the code you want. But there are other ways where you can say, I want to find where the space is and stuff. You can do, I want to find where the space is it? Find, right? Find the text, the space, right? In here, where is the space? It tells you it's 4. Okay. So if it's at 4, then I don't know. If it's at 4, right? Then what I can do is incrementally here. I can say left using this same string, right? I get the 4, is it? So that I'm starting from 4. Right. No, it's left. Well, I'm trying to get beginning at 4 here. So I guess you can say, what am I doing here? I wanted to start from here, right? I guess you'd have to use right in this particular case. Is it right? Right. I've found the index. I was looking for an index where the space is, and I want to begin. I guess you could say right here. Right, followed by len. This is what I wanted. The length of this, right? Length of this minus the find. Is it find where the space is in C3, so that it gives you the code you want. This is how you want to do this. Not that it matters really, but it turns out that these things that you do in this is a fun formula I was using. These things that you do in, let's say, in spreadsheet applications, you can actually do them in Python using string functions, right? Find in CSC 6741. Please find space. It's telling you that space is at index 3. Now, unlike Excel here, where indexing doesn't begin at 0 here, 0, 1, 2 is telling you that it's at 3. You understand this, you guys? I don't know if maybe we should find time and look at string methods. I don't know, but I don't think they're useful in any way. Maybe
Look, I have a question.
Yeah, sure. I can give this as an example. So go and look at these. There are a few, right? Clifford and stuff. Please, what is the question?
Do all methods end with open and closed brackets?
Yeah, wow, great question. So here's the thing about a method, right? A method is a special type of function. How is it special? It's attached to an object. So everything we've been doing with functions, we do with methods, with the exception that we evoke them or we call them with the dot operator, dot method. That's it. So the same way we are calling these functions we've been defining fx add or type. The only difference is the methods are going to be called with a dot operator. So meaning that there's object dot. I don't know if that makes sense. This is what we're doing here. The string object dot the method. So they all have, they need a open parenthesis, close parenthesis. However, you notice that the string functions have been calling, like find expects a parameter, is it? You're telling Python to say, I want you to find this character in this string. So I want you to find the space in this string. I can also say, I want you to find where S is. For some weird reason, this would be, but why? 1, right? Because it's 0, 1. Okay. But however, look at this. I'll use another method that is title. Okay, not title, but lower. Lower doesn't expect any parameter in here. Why? Because all it does is it takes this string and it changes the casing from whatever it is to all lowercase. All lowercase. Same as title. Right? It changes the string to title casing, where the first character is going to be uppercase. Everything else is going to be lowercase. Same as upper. Right? It's going to get the string, convert whatever it is here to all uppercase. And by the way, there's nothing like uppercase 6 or 7 here, right? The uppercase characters are just your alphabetical letters here, if that makes sense or something like that. But you know, I don't know which other functions are. Join, right? You know, you can join strings. You know, I don't know. Look at this, is alpha. So if you have you could be writing logic in such a way that before you perform an operation, you want to check if the piece of string is made up on just alphabetical letters, right? This is false because there's 6741 here. But if I check is alpha CSC, it will be true, right? So you see that there's certain functions that you use to check for, but you know, I don't know what else we can check. I don't know what other interesting functions. So it's a nice introduction to method. Is digit to check if the string has digits. And this is important, right? Imagine a situation where you're performing mathematical operations like subtraction or multiplication. Well, if a piece of string is not a digit, it's not made up of digits, you don't want to have a condition. If var input is equal to CSC 6741, input 1, and then var input 2 is equal to 2026. So you can have a condition if var input, in fact, you have a function here. You're going to say df, this would be nice, fxn, add inputs, add input, and this is your input. You can have a condition here, is it? You could say if var input dot is digit, then what do you do? Because if this is true, what do you do? You could say print, we're just going to add 2 here so that we see, oh, this is the beginning year here. When I'm going to, I don't know. We're going to say print add, because this is going to be a string here, the input, I'm assuming, cast it, and you say var input plus 2, so that we see when somebody is going to graduate. Else, you want to be descriptive. Print input is not a number. Enter correct number. So that if I run this var add input here, it's a weird example here, I don't know if it says, and I feed it var input 1. Input 1 will print that error message because this as a component is not a digit. But guess what? If I feed it input 2 here, it will show me 2028 like this. I don't know if this is a nice way to segue into our discussion of objects, right? So methods, functions are standalone, whereas methods belong to an object. You evoke functions in isolation. So the name of the function with an optional list of arguments if that function is defined with parameters. And then you evoke your methods using the dot operator. So it's object dot method followed by arguments. Now you will see this. We're supposed to start looking at data structures like lists. So if you want to append, look at this. You have a list. I have a list of scores for students, right? There's a 55, the vote passed, I guess 66, 27, weird here, 88, 99. Maybe, okay, for good measure, throw in a 40 or something like that. What type is this? This is a list object. A list object has a whole range of methods associated with it. We'll talk about this here. I can remove things, I can pop, I can insert objects in between, right? At a given position. I can copy, create a shallow copy. I can count the number of things in the list object. And begin to notice here, I can't, there's no count inbuilt function. So if I want to count things in a list, I would have to use a dot count. Right? Count occurrences of how many people got 99? 1. How many people got 45? No one got 45. But where are they? Oh, there's a 40. How many people got 41? You understand this? So methods are evoked by using the dot operator ideally. So these are a series of examples. So and there are a number of objects out there. NumPy array objects, right? Objects within the pandas library, matplotlib. The way you know the math package as well, right? If I want to perform mathematics, I'm writing a program that is going to use mathy things here. I'll import the math package, and guess what? These are the things that are in the math package. So if I want to compute the sine of 90, math dot sine. Sine 90. I don't know what sine 90 is a math major. Is this correct? I don't know. What is sine 180? I don't know. Sine 30.
Well, Doc, why are some methods having two underbars on either side?
They're called, we'll talk about, they're called, those are called dandas. They're special in a certain, they're special in a certain way, right? Python has, Python has a very fine, the people behind Python actually have a funny way of calling these things in Python. They're called dandas, double underscores, if you will. They're special in a certain way. So for instance, when you're creating, what do you call this? Constructors, you use dandas. They're called dandas, D-U-N-D-E-R. Okay, so it's short for double underscores, dandas, ideally. You find in some instances they're referred to as magic methods. I know this is like tied to Cell Magics, if you remember your Jupyter notebooks here. But it turns out that Python will use them kind of like implicitly when you perform certain actions. Ideally, like if you're trying to initialize or print a representation of an object, for instance, you'd use a double underbar, what do you call this? Double underbar str, for instance. So ideally we're supposed to cover, maybe we should. We're supposed to cover this if we are to look at object-oriented programming. So how you create classes and constructors associated with classes and things of that nature. I don't know if that makes sense. Maybe we should, I can plan for us to have, I think we should though. You know, I was trying to, here's the thing, colleagues, you see now, we have to, what we are doing here has got to be rooted in, I don't know if maybe I didn't share that. I think it's on the Google Classroom also. But it turns out that we are following a script here, right? They've told us what we're supposed to cover in this course. So when I say maybe we should look at classes, I have looked at the course outline, and nowhere in the course outline do they say we should look at object-oriented Python. And so to avoid wasting time, we're going to skip that. This is when we're going to look at to look at these Dunder methods ideally. But what you mostly use them for is you are performing operations on your object, an instance of the class ideally. Okay, so so for instance, your I don't know if I'll be able to do this. I think I should be able to do, what is this now? I think I should be able to do this. Math.doc. You see this, what this attribute does is it prints the doc string. Remember what I said about the doc string? I'm going to show you here. I want to create a function here which is going to add, I'll call this addx, fxn. Okay, I'll call this fxn new add. Okay, new, yeah, okay, new. fxn name, right? So you're going to print out hello name or something like that. Var name. Remember what we said about doc strings? 1, 2, 3. 1, 2, 3. And then we said what? This prints a name. This is a very simple function. And then I'll just say print hello var name. So what this function is going to do is it's going to just print out. If I just give it CSC 6741, you just print hello CSC 6741. But observe, if I say I want to check what is in here, you notice that where is it? There's this doc object, like this Dunder doc here. If I call this dot double underbar Dunder doc double underbar, it will print that thing that I defined here. So it's like it's kind of like a nice way of gaining access to important things that will be tied to objects of that particular type. Don't know if this is making sense here, but these are, all of this is found in the documentation. Some of this you probably won't even use. You know, you rarely use unless if you're using object-oriented programming idea. So the rule of thumb here is that when you're using objects, like in math, if I do dir math, I'll just ignore all of these Dunder methods here, these Dunders here. Everything is double underbar because I won't really use them. They're useless. What I use are these other things here, right? If that makes sense. Oh, but what is remainder here? Math.remainder. Wow. Is it 4 and 5? I don't know what this does here. 5 and 2. Okay, it gives a remainder, but I don't know why. Why is the remainder -1 for 5 divided by 5? Remainder is -1. I don't know, but okay. So that's the thing here. I don't know if this is making sense. Are there any other thoughts or questions about methods and functions? You will see them. They are here, whether we like it or not. When we look at the Python pandas package, observe. In Playground, I have this file. So I'm going to come here and then I'm going to say, I'm going to import pandas as PD. And then I'll say var records is equal to PD dot read underscore CSV. I'm using the read method. And the way the read method works is that it has a parameter which is a file name, another optional parameter which is sep, right? Specifies the separator and the CSV. And this is supposed to be the relative or absolute path. So this is in playground, like that. And then, so you notice here what I've done is I've accessed this. Observe, if I look up, what is this type here? It's a function, but it's a special type of function because it's within this object, this pandas object, right? So pd.read, is it? Or you can do a help, I guess. I don't know. I don't know if help on function. Yeah, they're still calling it a function user, but the correct term here is a method, special type. You can, so I can't come here and say read CSV here. It's too fair. Read what? There's no read CSV here. It doesn't exist. Unless if I want to use that nasty way of importing objects, right? I don't know if this is making sense. Are there any other questions about this?
What's the difference between a module and a library?
Yeah, that's interesting, right? It's usually it's contextual, right? But they're both ways of trying to extend, trying to extend the functionality. In fact, there's even things like packages, modules, and libraries or something. But simply put, in Python, right, these words are used interchangeably. It refers to how your code is organized ideally. In Python, technically speaking, here's the thing. Maybe we should do this here. Observe, maybe this will make sense here. I'm going to start off with, I don't know if this will, I think so. Playground, I'll go in playground, I guess. I'll create a module. In Python, a module is just a single Python file. So I'll create a module called csc6741.py, right? Oh, it's already here. Okay, I'll rewrite this. And then in here, I'll define a function like fx csc, okay, fxn csc 6741 add. I'll just return var a plus var b. var a, var b. Okay. And then I'll create another function, csc6741 underbar mort var a, var b, return var a multiplied by var b. Okay, for good measure, I'll just create, and this is retarded, there are no doc strings, but that's okay also. Var xn csc6741, I guess, I don't know. Div, for good measure, right? We just divide var a and var b or something. Return var a divided by var b. We could probably change this or something. Now observe, in an ideal case, right? You don't write programs like the way I've been doing it here. Like nobody does that really. Where you're using this, right? And in here is where you're writing code. Rather, you put in a module file and then you say import csc 6741. This is a module. And guess what? This module I can then use I can use the dot operator here to call different functions that I've defined. In fact, I can run the dir function here to see what is in here. So these things that I've defined here. This is like a module, right? It's a single Python file which ideally will have different code constructs. It could be classes, there could be functions in there. So that when I package this and I send it to you, you'll be able to call this function. So I would say in this particular case, csc6741.fxn this add, right? And this will work. What is 9 plus 8? 17 or something like that. So if I were to kind of define this, I would say a module is just a single Python file, right? A single Python file that ends with putatively with a .py. It will contain a range of reusable code constructs like classes, functions, variables, and all those things. Okay? A package is a collection of modules. Okay? So typically, this would be it could be like a folder or something like that. A folder that will contain like multiple PY files. And this is the reason why I've been doing this, right? I've been going to this hidden file here, VNV, I guess, I don't know, lib, and then I go here. I've been telling you to say, but why? CD. I've been telling you to say everything that I've installed in this I'm just going to change back to this. Everything that I've installed in here, these things that I've installed here. The way Python works is all I'm doing is I'm going on the internet and then I'm downloading these files. They're compressed probably in zip file, and then I'm copying them or I'm storing them on my file system. So if I go inside packages, the things I've installed, these are folders. There's Seaborn, there's SciPy, right? There's I'm going to go into my pandas library, right? There's pandas. There's a pandas directory here. So this is because in pandas you have a series of these folders here. These folders are called what? Packages. Because inside each folder here, you have a range of .py files here. Modules, colleagues. So what are we saying? I don't know what is in the TOs here. I want to find where, but you see now, where's the data frame? It's okay. So a package, it's like a folder. It's a collection of module files that are grouped together in a directory. Okay? That's it. It's a package. Right? So if you have a folder, like in this particular case, I have folders, API, arrays, errors, core. Inside these folders, there are .py files, which are modules. That's called a package. A library is going to be like pandas library. There are going to be a collection of packages. So there are a number of packages: plotting package, core package, errors package, arrays package, API package. Don't know if this is making sense, but you know, this is the context. It depends on the programming language here. But in terms of Python, that's the hierarchy. I don't know if this is making sense here, but you know, I don't know where the math package is. I want a simple package to see if all the things I've installed. What about matplotlib? Matplotlib. Okay, maybe instead of the terminal here, I'll go into my, guess this is confusing here. It's like I'll use my Dolphin here. It's like this, right? These are the things that I've installed, right? These are the, and this is, this is where it becomes a bit tricky here, because sometimes people will call, oh, install the Jupyter library or Jupyter, you know, package, install matplotlib, it's a library anyway. So in this particular case, these are the different things that I've installed, right? These in here for this course. And how do I know this? Guys, I know this because I'm using pip. If I do pip list, I'm listing all of these things that I've installed. The ones I was listing by doing pip install and stuff, right? Package name. So I expect all of these to be folder names. Why? Let's call them libraries. So there's supposed to be a matplotlib library. Matplotlib, where are you? Matplotlib is here. Is a folder. It's here. I'm going to zoom in again so that we matplotlib. Why is it a library? Because if I go in here, there will be subfolders. These folders are called what? these technically speaking are supposed to be called packages, right? They're different packages, ideally. But of course, I mean, this is kind of like an interesting library because right in the root is where you have things like pyplot should be here, but where is pyplot? It's here, you see this? And this is the reason why, if you remember, when we're using pyplot, I do what? I say import matplotlib.pyplot, right? So I'm saying, go into this library and I want you to use this module. So there's a file, pyplot.py. It's literally Python code, by the way. So there are people like you and me that just wrote this program that helps to plot things. It's quite lengthy here, 4,644 lines of code here. In this module file, there are functions. I have no idea what these are, plasma and all those. I don't know if I've answered your question here. I'm trying to, but maybe we should do classes though. But they've told us not to.
Yeah, it's made sense.
Yeah. You know, we're probably not, we're not going to look at classes. We don't have the luxury of trying to look at classes. It's not part of the syllabus. But there should be a tutorial in the official documentation which discusses classes on Python itself. So if you go to docs.python.org, there's a description, a whole description. If you're interested in diving deep into object-oriented programming and stuff. But also these things we're talking about, by the way, they'll make sense because all of these other things we are looking at after. Can I context switch again? All of these things that we're supposed to be looking at. I want to change these. These are modules. These are not lectures. These are not topics we're looking at. These are modules, really. If you remember, at the very beginning when we were looking at the introduction of this course, we said that we're going to do what? We're going to this is it. Now, once we are, what we're looking at right now is this. We're about to segue into our discussion of this. Once we're done with this, we are supposed to start looking at individual packages. NumPy, not difficult really. We're supposed to look at Python pandas for data analysis. We're supposed to look at matplotlib and Seaborn. We'll probably just look at matplotlib, that would be sufficient. We're supposed to look at how we use Python to preprocess data, to normalize data and all those things, right? How to handle outliers, in essence, exploratory data analysis. Now, what you notice is that I'll call this modules, module number 3, we start looking at specific libraries, these things that will be installing, like import NumPy as NP, right? And if you say, what is NumPy here, it will tell you, it's a library, is it? I guess, I don't know. It's supposed to be a library or something like that. I don't know why the description doesn't specify that this is actually a library, right? But it's supposed to be, a very detailed library and stuff like that. So some of these things that I'm talking about, like dot operators, will make sense, right? You will notice how they'll make sense. Don't worry about this. Anyways, hopefully this is making sense. And then, what I have here is just an example of how you use a method and a function, right? So I have a list, var list, with 3 elements, 3, 1, 2. I use the sorted built-in function. I just use it like it is, sorted. It comes bundled in. The moment you run the interpreter, you install Python, you will have access to sorted. It's there, right? And the way it works is it's supposed to sort. It's supposed to sort these things in a certain way, right? So -10 comes before 1, followed by 40. So sorted is a built-in function that sorts, right? It sorts an iterable object ideally, right? But it turns out that if I'm working with lists, let's say I define this as a list, I can as well use the built-in function called sort, right? That is going to sort the list ideally. And this will make sense if I'll call this var x is equal to this, and then I'll do var x dot sort. And then if I run var x here, notice it's sorted. So it modifies the original list idea. And I'm just demonstrating here, both sort and sorted do the same thing, except what the one I'm calling on the list object here, it does an in-place operation, meaning that it modifies the original list idea. Okay? It's different behavior, but the thing is the same. Whereas this one returns a new copy, and this maybe it won't make sense here. It makes sense because I can do sorted for another iterable object, is it? -10, 4, 5. Right? It returns sorted list. Okay. Hope this is making sense. Are there any questions about functions? I think we've had enough of functions. Okay.
That's did you share the course outline, the one that you're showing now?
Yes. These are on the, I don't know if you're on the Google Classroom. There's a document, it's like a picture document, and there's also the slides and the recording. Yeah, so it's there.
Okay, sir. Thank you.
All right. I do hope we are. This thing, by the way, unfortunately, this is probably different from these other courses that you have. Before we continue here, maybe it's a nice way to segue and to pause a little here. I can continue on and on and on here, but you know, this course is different from this, very different. Certainly different from this, right? Where you can perhaps memorize things is different. I don't know what sort of things they're discussing in Introduction to Data Science. This is a hands-on thing, right? The only way these things will sink in is if you do what I do when I'm trying to demonstrate things. I'm showing you, well, I use the terminology, it's quicker like that, but if you try out things, right? We discuss concepts and you try them out over and over again, these will begin to make sense. Otherwise, it's and it's not stopping, right? Is it? You know, this is supposed to be like a practical course here. These other courses are supposed to lay the foundation, ideally, colleagues, but fundamentally, especially as we get into I want to say beginning next term, because we are laying, you see what we are doing this term is we're trying to lay the foundation, right? The foundation for what is supposed to come our way. Okay. Now, there's supposed to be a lot of, we're supposed to look at a lot of hands-on courses, if you will. You know, so yeah, which is why a lot of these things, we assume, I think the best language that is supposed to be used here is supposed to be, I believe it's supposed to be Python for the most part. You know, if memory serves me right here, if you start looking at the entire, you know, kind of like program document here, you will notice that the things that you start looking at beginning, I want to say beginning next term actually. Fundamentally, they're going to be kind of like hands-on. So this thing, what I want to say is this thing is not going away. And I imagine this is the reason why a lot of you are doing this, because maybe you anticipate that you're going to be doing this at work and stuff of that nature ideally. So I don't know, if I were you, I'd practice a lot, so that these things here make sense. Like for instance, next year you're supposed to have, I think there's a mainstream machine learning course. That's like programming, classic programming here. Of course, I mean, you have things like advanced statistical methods. I guess there's a little bit of math there, but all the other courses are like hands-on, and they assume that you've been introduced to Python, right? Because Python is used as the base language for the most part. So there's a dedicated course for data visualization. You're going to be programming in Python. This is next term. I'm not sure if it's that thing here. There's a machine learning course, and then I think in year number 2, you have more focused approaches, right, to data science, like how do you process text. So you're supposed to have, I think in term 1 or something, you have a dedicated course in natural language processing. Again, that's Python, right? Although what you're doing is you're using specialized packages, libraries, like GenSim, NLTK, right? A whole range of like natural language processing libraries, I guess. I don't know. So they're supposed to be like deep learning and all those things. So this is a hands-on thing here. Anyway, if I were you, I'd try out this over and over again so that this sinks in here. If not for the exam, for what's coming next term. Because in the exam, I mean, it's like we're sitting here, right? What sort of questions can you ask here? They have got to be programming-centric questions. Write a program that does this. So the only way you'll be able to figure things out here is if we understand. Okay, but that's, we know. Now, you see now, if we're going to proceed here and maybe talk about, because I wanted us to, I don't know if we discussed this already, but I just want to quickly talk about this issue of modules, right? Because it's somewhat tied to methods, and then very, very soon, once we are done with our discussion of Python data structures, its native data structures, we're going to move to start looking at these dedicated modules ideally. So just briefly here, right? What is a module? And I think it's tied to the question that was asked. A module is a file that contains Python code, a .py file. What I have been doing in the examples I've been using here is not how you would write Python code. You don't go to Jupyter Notebook and then you start writing your Python code. If you are writing something complex or a piece of software, right, that can be used in production, what you do is you write your code, you encapsulate your code in module files. And I'm glad I started off by showcasing how this is done in Playground here. You notice I created a module file called CSC 741. And in here, I'm including what? Code constructs, functions. They're going to be methods because I'll be calling them using the dot operator. For me to use this module file, what I do is I import the name of the module, CSC 6741. Boom. I have it. Okay. And Python has its own way of knowing where to search, right? It recursively searches. If you say import X, it's going to quickly search through, right? To find if there's a module, there's a file called x.py somewhere on your computer. In essence, by default, it turns out that Python checks for module files in a certain way, right? It will first of all check if you run an import statement, right? Python, ideally, it's supposed to scan the entire file system, ideally, right? But it uses a heuristic that prioritizes certain locations on your file system. Okay? So if I do import X, Python will first of all check if this X is associated with an already existing module, a built-in module. Like for instance, you did not see me do pip install math. Why? Because math is an example of a built-in module. If you know what I mean. Just like we have built-in functions, if you remember. I was using the import. I did something like import, if you remember, built-ins like this, and then I was able to check, is it? Hey, do we have what sort of built-in functions do we have? Right. What we can do is we can, and this is funny, right? There's also a built-in module called sys, right? So I can use sys, dir sys, right? It's all over here. System, right? Sys, short for system. It's weird here. What I can do is I can do a sys dot built-in module names. Right? So what this thing does is it's listing the built-in module names. Observe. But guys, what I can do is maybe print them nicely. This is enumerated, right? Can we use for loops for var module in here? Print each module, right? One line at a time. So all of these things that you're seeing here, these are built-in modules. They already exist. Okay, let's forget the ones that start with by here. Like there's an array module. I've not used it myself. There's a texted module, not used it before. I don't know what this being ASCII one is. Built-ins, we know the built-in module, right? It's the one we're using right now. CMath, I have no idea what CMath is. Error number, I don't know what this is. GC, I have no idea. Math module, it's built-in, right? The sys module, built-in. Time module. So the idea behind built-in modules is like there are these common use cases, right? For Python, or it turns out, irrespective of what you're using Python for, you are more likely to use some of these modules. So rather than having them as external modules, they're available to you by default. Okay. If that makes sense. Anyway, if that makes sense. So the idea here is that the way the heuristic works is that what Python will do is it will first of all check when you do an import, like in this particular case, import x. What Python will do first is it will check, is this x a built-in module? Does it exist already? Is it part of the interpreter when it was installed or something like that? Okay, so it checks. These are called standard. They are called standard. What do you call this? Is it standard? They're part of the Python standard library, if you will. Okay, they're baked into the interpreter ideally. And then, if it doesn't find that module as being part of the built-in modules, part of this list here, it will check in the current directory. And the current directory here is when you're running Python here, you're running it relative to somewhere, some location in your directory. Like in this particular case, I'm in here. So in Playground here, I have a whole range of module files here. So it will check, is it in the current directory? If it's not in the current directory, what it's going to do is it's going to check if the module is part of your Python path, right? So the idea here is just say which Python, I guess. I don't know if I'll be able to get, I won't find this because I haven't activated it, but if I say which Python 3, I'll be able to find it. So it will check the path. But if I do source.v and v be this, it will which Python to be able to find this, right? So it will check in here, in my case, because I'm using this Python environment, is it specific to this course? It will check, is this module in here? Now you notice in my case, right? This location here is where I'm installing all of these different things. I'll open a new folder here, in here. It will check in here. In here. right, in library in here, site packages. So to check, is this X appearing in here? Right? And then you check so there's this hierarchy here. You know, there are specific certain types of standard library paths and then site packages as well. Until it finds it, right? If it doesn't find it, it will tell you that, observe, import X. It has not found X anywhere on your file system. It's not there, so it doesn't exist. I don't know if this is making sense here. So a module is a file containing Python code, and what you do is, for you to use this file that contains Python code, you must import it to reuse it. It's the idea behind modules is similar to us creating functions. If you wanted, you observe, if I want to do anything mathy, I'll use math. I don't know about CMath. I just discovered there's CMath here. I have no idea what this crap is all about, CMath. But we can check here. I don't know what this is about. CMath and math, I don't know what the difference is. I've never used CMath myself. Oh, mathematical functions for complex numbers. Oh my God, CMath, complex numbers, right? So you notice CMath has the same, if I do DR for CMath, it's the same as the normal math, right? More or less the same, similar kind of things. The sign for complex numbers and stuff like that. So the thing here is that, think about this for a second. If I want to write a computer program that does mathy things, all I'll do is I'll be writing that program by doing import math. And then I start running things, math dot something. The other option I could have done is I'm going to say, I will write my own math package. Because I understand mathematics. If it's like one of you guys who majored in mathematics, you know what math is all about. All you're doing is you're converting to code all the ideas, the core ideas about math. But if you think about it, right? If somebody else has already figured out, has already written a program to do with math, why do I have to rewrite it? Why can I not just go and get what has been written by somebody else and reuse it so that I am more productive, so that I avoid the errors and repetition? I mean, think about this for a second, right? It's like, but people do this, right? You want to build a house, right? There are people that are already making bricks, right? No, I want to make my own bricks here. I'm going to buy my own molding machine. Okay, but you can do that, I guess. I know it's a word example though also. But I'll buy my own molding machine and then I'll make my own bricks. I don't know why you're doing that, right? You're wasting time. It turns out that it's cheaper for you to, and I hope I'm not talking to myself. I just noticed I hope I wasn't talking to myself. I just noticed my phone connection.
Oh, we can hear you, Doc.
We've been hearing you.
Oh, thank you. It turns out that it's easier for you. You're going to be much more effective if you just go, and they're sold everywhere now, right? Concrete bricks. You just go there, and you're like, well, I'm looking for a brick that does this. Here's the thing, and I forgot to, and I want to do this as a launching, as a way to motivate for this, right? If you go to PyPy, right? If you go to PyPy, this is a huge repository, right? Python package index, a huge repository where you find modules, all sorts of modules. Guess what? How many projects do you have? 770,380 projects, right? These are 17,891,813,000. So think about this. If you're looking for anything to do with mathematics, and the CMath and the math package are not sufficient for you, you just go to PyPy, and then you find, right? Are there any interesting modules in here to do with mathematics? Right? And hopefully if my internet is working just fine, I don't know why it's not. You'll be able to find interesting packages from here. Incidentally, when you do pip install, you find them. Let's try and, because there are a lot of mathematics. I'll just say best Python math library. So in addition to the math library itself, is there anything else that you can use? Okay, it's the usual SciPy. Yes, we know SciPy, NumPy, which is the same. Oh my God, math mode, which is generic. Okay, I don't know if there's anybody who's done physics here. Best physics libraries. I don't know. If okay, same NumPy, Matplotlib. Oh, SymPy, right? PyMonk. I've never used some of these things here. Brax. Oh, wow. So the idea really is that instead of reinventing the wheel, just in fact, I'm going to stick to the house here. You're building a house, right? If you want, now you'll be viewed as a very strange person here. You're going into a stage where you're putting the final finishings, right? The glasses and the doors, and you decide in your reptilian brain, it's like, I'm going to build my own door, right? So I'll learn how to do woodwork, and then I'm going to create my own door. I will create my own windows. Nobody does that, right? You go out there and you go and buy doors. You go and buy windows. That's the idea behind packages, right? For things, common things, what you do is you go out there and you get those those modules, ideally, or libraries. It's called there's a name in computing for that. It's called software reuse, right? You don't have to do things from scratch, and this is quite common actually. Even when you're building complex applications, I'll give you an example of the UNZA library, right? Nobody in the Center for Information and Communication Technologies sat there and started creating this website from scratch. Nobody does that in computing, right? In software development. I have a blog. I did not sit down. I could have done that. I did not sit down and I'm writing all the code associated with the different features of my blog, right? I didn't do that, right? I reuse software. That's the essence of using modules, right? And functions, right? It's centered around software reuse. So this notion that for common use cases, you can go out there and find libraries that will be able to do the things that you want to do. And you notice here that when you're programming, there are certain common use cases, right? Whether you like it or not, at some point you will need to read files from the file system. If you're doing data analysis, okay, if you're a data science expert, you will be manipulating data. You will be building inference models, right? You will be performing computations that will need to be efficient in terms of handling numbers. NumPy, you will need to graph things to visualize things. Matplotlib or Seaborn, right? Or a whole range of, and people are always busy creating these generic reusable libraries, right? Python, visualization library. You will find them there. I know Matplotlib and Seaborn are going to be top of the list here, but there are more. It's not they are not the only ones, right? I can use Plotly if I want to, right? Some of these weird things I haven't even used, right? You can use Plotly. I don't know what these are here. I've never used these things myself. You know, if you're doing GIS-centric things, there are libraries that will enable you to read shape files, for instance. I've never used Plotly here. And whenever you see get demo here, it means this thing is not freely available. It may be nice, but it's not free. It's not open source and not freely available. So I would stay away from things that are not freely available here. So modules really are more about reusability. And it's just unfortunate that I can't find, maybe we can browse here. Browse projects. If I browse projects, maybe they are categorized in a certain way. And maybe we can, maybe as we have seen this, you can tell me what sort of, if you have thoughts on what sort of, I don't know why this thing is misbehaving here. You notice how these libraries or something are organized based on whether they're organized. So these libraries are organized on whether they are tied to specific use cases like natural language processing. Remember, I was telling you that you have a dedicated course, natural. You know, I teach natural language processing. I do that a lot myself. We do a bit of text mining and stuff, right? So natural language processing, you will find that, observe, if you just say NLP libraries in Python, Gensim, NLTK, right? SpaCy. I've used Gensim, I've used NLTK because there's specific types of NLP tasks and problems that we do with students I work with. Certainly I've used spaCy in the past, but some of these things like Hugging Face, transformers, never used that before, no idea what it's about here. But they're all, these are all module libraries, right? So what I'll just do is I'll go to the website for the library to just get instructions on how to install the library itself. And then that's it. Right? I'll be able to use it. So it's all about reusability. So in this particular case, if I want to use PEEP, I'm using CPU. I think I have GPU actually. Hardware, I'm using a virtual environment. And then I have details here on how to install. Boom. So if I wanted to install spaCy, I'll just use something like this here. PEEP install spaCy. Boom. And then I'll install the entire spaCy library. The same goes for Gensim. But anyways, so the modules are centered around this notion of software reuse or reusability, right? There are modules that are inbuilt, they're baked into the interpreter. There are modules that are third party, so you can use PyPy to install them. All you need to do is learn how to search for those modules, where to search for them. PyPy is the best way to get started, or you can just do a word search. In fact, these days, you can just do what do you call this? You can use an LLM, is it? ChatGPT, and just say, please list libraries to be used for ABCD, for reading JSON files or some crazy thing like that. Okay, so there are third-party libraries. These you install or showcase how you install them using PEEP, or at this stage, actually, you can write your own module files and your own libraries. And think about this for a second, right? If there are some of you that work for telecommunications companies. You see, what you do on a day-to-day basis, I've worked in the telecom sector here, is the same thing, right? And life sometimes, I don't know why we do this. We do the same things over and over again. If it's me, around this time I teach. Okay, this year is different, but next year I'm going to be teaching these same things, right? It's the same. So it's like you, if you're working in this telecom sector, what you can do if you are smart is you can create a library that is going to be specific to Zamtel or Airtel or something like that. If you work for an insurance company, Madison, our colleague there, you write modules, right? So that people that are going to come after you will be able to retrace your steps. All they'll be doing is they'll be doing whatever it is they want to be doing by importing those libraries. So it'll be like import Madison or something, right? And then you say Madison dot whatever. Madison dot whatever. Then they're running all those things. So in essence, there are three main ways of using libraries, right? You can use inbuilt libraries like math, right? Yeah, or these things here, system dot modules, right? If you remember what we're talking about here. Yes. syslog, so they're inbuilt or time. But guys, import time. I don't remember what sort of times we have here. Time dot, I don't know. You can make time. It's crazy here. You can do a lot of things with time. I haven't used the GMT time. GMT. Oh wow. Yeah. So they're standard library modules, right? They are baked into the interpreter. There are third-party modules. The modules that we're going to study in CSC 6741 are third-party modules, right? So you typically would install them by pulling this information from PyPy. But there's a comment here. Someone is just responding, say, okay, now. I don't know if they're going to be in the thing here. Right, so there are third-party modules. So the idea here is, the question you're asking yourself is, where exactly does Python pull the pip modules idea, right? It turns out that what pip is doing on your behalf when you do pip install, and we'll talk about pip install just now, is going out there on the internet and is going to the Python package index, PyPy, where I went to in here. It's an official repository where you find Python-centric things in here. It goes here, right? So when I do pip, it goes here and then it pulls things from here. Okay? So it's putting these things among. So in your case, if you are smart enough, I don't know if we have Zambians that have done this already, you can actually publish your modules on PyPy so that other people in Zambia, think about this. Maybe it's we don't think about this as master's students. You're doing advanced degrees, but we don't do this. You can write a module, right? That is going to be an NLP module for Chichewa or Ichivemba or Silozi or Ishtonga or something like that, right? So that when other people are doing language-centric things using Python, they'll just do pip install Chichewa or something like that, or Silozi. But we don't do that. So you can publish your libraries there so that other people pull them. So in effect, what you do, and I'll talk about this, what you do is when you're doing pip install, let's say pandas, I'm going out there on the internet on PyPy and then I'm downloading those documents and then installing them. It's the same as me going here and I'll search for pandas. If I want, it's here. I can go here, powerful data structure, blah, 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 and I can download the files manually. However, the problem with, and I know this is the one here because you notice the number of folks, I don't know if the number of downloads are here. Downloads maybe. They're not here, but they're even telling you how you should install this. But if I wanted, I can manually download this and just unpack the files somewhere in my current directory. It will work. But the only problem there is that when the version changes, because versions of libraries change often, there was a time when Pandas was not version 3.0.1. Okay, so what do you do then? You have got to update and using a package manager. So pip is a package manager. This thing here, this is called a package manager, right? Different types of package managers, but it's a package manager. It allows you to install packages, to download them, and install them if you don't want them anymore, I guess, and update them as well. You can update packages if you want to. I guess, I don't know. Anyways, so hopefully you'll be thinking about this in the next 2 years here. This is what we should be doing, right? We're doing these advanced degrees and we should be thinking beyond just learning how to create, how to use Python here. But it's like, how can we take advantage of Python to try and make things better in Zambia? There are different use cases. We're coming from different sort of places, right? Workplaces, that is. We do different things. There are different use cases, but things that can be applied elsewhere or in related domains. It's create libraries that are specific to Zambia or something like that. Now, the thing here is, when you have a library, the question is, how exactly do you use it in your code, right? I want to write a program that uses mathematics, math-centric things. And I discover that the math package has the functionality that I need. Well, what I do is I import the module. Now, so I use the import keyword. Surprise, surprise. If you remember that, right? When I said import keyword, and then I say keyword.kwlist here. Import is a reserved word. Is here. So the way we reuse modules is we can either use the import keyword followed by the name of the module. I want to import the math module. Boom. You have access to the math module. Now that you have access to the math module, you can write a program. Typically, this is the very first line you have, right, in your code. And then you can start calling things within this math module. Math.sine. What is sine 0? I don't know. It's 0. What is cosine 0? Okay, it's 1. What is tan 0? It's 0. It's crazy here. Guys, colleagues, I wanted to show something here. Okay, maybe I'll refer to it later on anyway. How I use in other courses that I teach, how we import these things, right? So you import packages. And typically in your program, when you're writing, that's a module file, right? When you're writing it, the import statements are going to be at the very top. That's the very first thing that you do. You are telling Python, say, what I'm going to do now is I'm going to reuse code constructs that are available in these libraries or in these modules idea. But it turns out that there are other ways of using the import statement. And you've seen me use this somehow in some examples. If for some weird reason I don't feel comfortable calling the math package with math dot whatever, math dot, oh, what is GCD of greatest common divisor? You know, guys, I did this myself. It was, I think, in first year, the GCD. I think we did the theory of the GCD, crazy things they used to teach us. But they've proven to be quite useful to me, especially in my chosen career path anyway. Like we're doing quite a bit of mathy things, not complex things. We're just doing vectors and matrices in computer graphics. And I was telling the fourth years I'm dealing with, say, I am assuming, sorry, we must break off and talk about some of these things sometime. I was telling them, I'm assuming that you've done this because in your, I don't know, I'm assuming you've done this because in first year, and I know they were not happy because they're in fourth year now, in first year, you did things that were even more complex than what we are looking at, literally, stuff we're doing here. I was telling them. But it's not stuff, this is complex stuff. We're just doing, you know, multiplications and stuff, right? But, you know, when you're not paying attention in first year and you're just memorizing things, you forget. Now you have to go back and you're looking at vectors or something like that. I don't know. But anyways, so if I'm not happy with math dot, what I can do is I can use an alias, right? So I can do import math as M or as M. And what I'm doing is I'm telling Python that I'm importing this package, but I want to refer to this package with M. You know, just like all of us here have our full name. If somebody asks you what your name is, right? It's like, it's your full name, right? Or Bikaling or something like that. But the way we refer to you easily is to just say Obi or something like that, or Kalenga, right? It's the same thing here. I have this package called math. I can import it. I can import the package name as an alias here. So that instead of math.gcd, I'll just say m.gcd, like this. It will work. GCD of 5 and 10 will still show me the same thing. Okay, that's one way of using a module. But there's more, right? If you're dealing with complex libraries, like matplotlib, you can do an import matplotlib, right? Dot pyplot as PLT. This will work. Boom. And then you start graphing at PLT dot py or something like that, I guess. You say 40%. I like this one. 40%, and then I say PLT dot show or something like that, so that you have your pie chart like this. But guess what? Well, what I can also do is I can say, I know that pyplot is a module within the matplot library, right? So what I can do is I can say from matplotlib I want to import pyplot as PLT. This will work as well. Matplot. I guess this is a horrible pyplot like this. Pyplot like that. This will work. So there's this other variation. You notice here, right? In the first instance, I'm just using one reserved word, import, followed by module name. The other option is import module name as alias. The other option is I can use from. Now, from is pretty interesting, right? Observe. In as much as I'm saying I can do it in this way, there are instances where you're dealing with a very complex library. Imagine it's math. Look at this. Math has a whole range of things, right? But what I'm doing may not be, for what I'm doing, it may not be necessary for me to use all of these things. In as much as I'm working on a math problem, maybe I just want to work with angles or something. So sine, I just need sine and, sine and maybe cosine and tan. This is where from becomes really, really useful. I can just say, instead of wasting resources, I say from math import sine and cosine. That's it. And when I do this, the interesting thing is when I selectively import things like this, I can refer to them directly without the dot operator. So in this particular case, I'll have sine 0. It will work. Cosine 0. Now there are certain schools of thoughts that will say, well, this is horrible. It's a horrible way of referring to importing things here because it's a horrible way of importing things here because it's difficult to know, right? It compromises readability. You don't know where sine is coming from. Is sine a built-in function? Is it coming from a math package? So what most people prefer is you use the alias, the dot, especially if you're writing complex code. And you see this everywhere. If I'm going to go back to these, if you look at pandas, for instance, the way it was implemented, if I just open one of the modules in core, let's say, I don't know, frame maybe. You notice that at the very beginning here, right, they're importing things like so. Import collections, right? Import ABC, right? Import these things so that somewhere at the bottom here, somebody is doing this collections dot. I don't know if this will work here. Collections dot, yeah. You see this, somebody is doing this. It's a lot easier. Now, if I just say from collections, import everything. And this is complex code, by the way. It's 16,710 lines of code. Yeah. So, but if I say, come on, if I say I want to use the from, it's going to compromise the readability, if that makes sense. You know, but I just thought I would mention this. And sometimes for math, I can do 3 different options. Import math, in which case I'm doing math dot, or import math as m, in which case I'm using them by doing m dot, or I can do from math import everything, in which case I'll have direct access to the things that are in math and better know what is in math, right? So I'll be able to run log 10 easily here because I've done import everything. The import asterisk here, the star, means get everything from this library, if this makes sense. Yeah, I don't know what's happening here, but it's crazy. Anyways, so I thought I would kind of mention some of these things here. You will see a lot of these beginning, I think, next week or something when we start with NumPy, right? Because we're supposed to transition to NumPy after we're done with our discussion of data structures, ideally. Okay. Again, the way you install modules is simple. Use pip. I think I already mentioned this at the very beginning when I was walking us through how to use these modules. You must remember though, if you are in Google Colab, you use the magic, is it? the OS level magic here, exclamation mark pip, and then install the package. If you are doing it locally, pip install, I know it's numpy, and then boom, it's going to go to the to PyPy and download that module and install it. If I want, I can do uninstall. I'm going to get rid of this. It will ask me, do you want to uninstall? Yes, proceed. I no longer have NumPy now. If I go in here and I say import NumPy as np, it will fail, right? Module doesn't exist. Okay, I know it doesn't exist. I'll do pip install NumPy. And really, the pip works in such a way that you can specify specific versions if you want to. It just goes to PyPy and then if I don't specify a version, it gets the latest version. So it's going there, collecting NumPy, right? It's telling me the version of NumPy that it's collecting. It's installing NumPy. It's telling me it's successfully installed NumPy. And now if I go back and I do the same thing that has failed and I say import NumPy as np, it will work. No news is good news, is it? If you remember, right? If no error message comes up, then everything is okay. Okay. What I have here is just some example of using, you see us use Python pandas. So first of all, install Python pandas using pip. And then afterwards, we start using Python pandas as follows. Now, I will explain this when we get to the stage where we're doing this putatively, right? When we say import Python pandas as PD, it's just by convention. Most tutorials that you find online about pandas, they will import pandas like this putatively. But if you want, you can do import pandas. But what you have to do when you're reading files is it's pandas.read CSV, not PD, right? Or NumPy. Most tutorials, putatively, by convention, you import NumPy by saying NumPy as NP, right? It doesn't mean that it should be NP. It can be NPY if you want to, or it can be N if you want to. But it's usually nice to stick to the convention. Or matplotlib, when you're plotting, by convention, it's usually matplotlib.pyplot as PLT. This is just by convention. It doesn't have to be like this. If you want, you can just say import matplotlib.pyplot, but then you'd have to do matplotlib.pyplot.py, which is kind of retarded, really, right? Because too many dots, is it? I guess this will work though. 46 like this, right? It will work, right? And then you'd have to still do pyplot.show, right? Which is really, it's not nice though. But it's not elegant, I guess, is what you'd say. Too much writing involved or something like that. You know, I teach a computer graphics course, and what we do is, I'm going to showcase this to you, maybe. I don't know if this is going to be useful or helpful to you. And what we do is we use these libraries. It's not as complex as what we're doing. I've done a whole bunch. But we use Pygame, OpenGL, and we also use NumPy as well. Right? These are things I don't know how I ended up installing them. I should have installed them. This is what in essence, what we do in this course is the requirements file is this. These are the packages we use, really. So NumPy, Pygame, PyOpenGL, and PyOpenGL Accelerate, which is used implicitly by PyOpenGL. Right? And the way we use these libraries is we have installed Pygame, PyOpenGL, so much so that when we are looking at running or creating a computer program, it may not be complex here, but if let's say I wanted to write a very simple program that renders a cube, right, like this. For this to work, right, what we do is, for this to work, and I'm going to open it right now. For this to work, we had to install Pygame. We're using Pygame, PyOpenGL, and NumPy. So at the very beginning of the code, we have these things here. Right? We are reusing modules, ideally. If this makes sense. if this makes sense. All right, unless if there are questions about modules, we can maybe move on to our next discussion, which is data structures. Is this too much? If it's too much, what I can ask of you is, I think we can stagger this, right? This is unlike the other courses I teach where we can have invited speakers and staff. It's different. So instead of doing a marathon for 3 hours here, we can proceed the next 30 minutes, but I was going to suggest we can do an hour, brief 1 hour on Saturday or Sunday if you wish. Or when is that? Wait a minute. Or we can do, I feel like it's, we've unpacked quite a bit here. I want to give you a bit of time on Friday. Yeah, because we had another session on Friday with you guys. So if you want, we can stagger this. If you don't have anything on Friday, let's have this an hour-long session on Friday, maybe 17 to 18 or 18 to 19. How is that? So that you have a bit of time to unwind, try and look at the things we've done here, right?
Okay.
I think Friday is okay.
Yeah, or if you want, we can continue here and I don't want to bombard you with a lot of stuff here, but because the data structures part is just we're looking at the core data structures, the list, dictionaries, tuples, sets, and then we're going to do list comprehensions, and then that's it. We are then going to move on to the next phase. So let's do Friday, I think. I'll wait for you to let me know what time. I'll leave you to organize yourselves and decide on whether you want us to meet at 17:30 or at 18 hours. We can just do an hour, finish off our discussion of what do we call this? Of data structures. And then on Monday, next week, we'll jump into NumPy. And our discussion of NumPy is not that complex. We'll probably immediately start pandas with. So we can leave it at that. Okay, so I'll wait to hear from you. Please, I know our colleague, Mr. Mwene, is quite diligent here. I'm sure he will reach out to me to let me know to say, we have decided that we're going to meet at 17:30 to 18 hours or something like that. All right, thank you very much. I will share. I know some people had requested for, you had actually requested that we share some problem sets. I will upload them as a notebook to help you put to practice some of these things here. And I've been trying to link them to some of the data sets that I'm going to be using actually. Okay, so thank you very much, ladies and gentlemen. We shall see you when you see us Friday. Bye. I hope Friday is not Good Friday, is it? No, is it? No, it's not.
Doc,
Yes. There's a question from them.
you'd also share the slides as soon as possible.
I've actually done that. So I was doing this at the very beginning. You notice that I was updating these slides. I've literally just updated them.
Oh, okay,
Because I made
that's
some changes.
appreciated.
So, yeah, the only thing that will take a while is this recording and stuff. Yes.
Is it also possible that you can share the program document for Masters in Data Science as you share the other materials?
Yeah, I'll try and share the entire program document. That's not a problem.
Okay, thank you, Doc.
All right. Good night, everybody, and happy programming. For these things to work, before things start piling up, I would strongly advise you to actually play around with these things in Jupyter Notebook or something. Good night. Thanks.
Good night.
Good night.